Hello everyone, welcome to my video. In this video, I want to explain about matrix. Before we start the lesson, I want to introduce myself. My name is Wayan Maeti, with student digit number 1913011026 from 3A Mathematics Education. So happy watching. Okay, for introduction about a matrix, we have to know what is a matrix. Matrix is a collection of numbers arranged in row or columns or both, and in parentheses. The numbers that make up a matrix are called the elements of the matrix. The matrix is used to simplify data delivery and making it easy to process. So, for example, here is a matrix of size 2 by 3 and matrix of size 2 by 2. Example number 1 is matrix 2 by 3 because it has 2 rows and 3 columns, so it has 6 elements. And example number 2, it has a matrix 2 by 2 because it has 2 rows and 2 columns, and it has 4 elements. Next, about general form of matrix. General form of matrix you can see in slide, whereas the general have 3 notes. In the first, the name of matrix must be capital H. The element of matrix A sub e.g. each row and G columns, and the last of the matrix M times N. Next, we talk about properties of matrix. Okay, the properties of the first matrix is transpose matrix. The transpose matrix is a matrix that is formed by exchange element in the row and columns of the matrix, generally symbolized by transpose A transpose like slide. For example, if matrix A and B are defined as full matrix A, 2, 0, 1, 4, minus 2, and minus 2, and element of matrix B, 3, minus 5, 1, 0, 1, 0, 7, 2, minus 5. And then the transpose matrix A and B, A transpose 2, 4, 0, minus 2, 1, and 2, and then B transpose 3, 0, 7, minus 5, 1, 2, 1, 0, minus 5. And the second is trace matrix. Trace matrix of a square matrix is the sum of the elements on the main diagonal of the matrix. So, the requirement for finding a trace matrix is that the matrix has the order m times n, or square matrix. For writing its symbols by trace A equal to TRA. And then the third properties of matrix is an inverse matrix. A matrix A has inverse if there is a matrix B which can form the equation AB equal to BA equal to E, where E is the identity matrix, the inverse. If a matrix with an order 2 times 2. And then the formula A inverse equal to 1 divided A times D minus B times C times the position of matrix order 2 times 2 like D minus B, C, and E. Okay, next, in the inverse matrix have properties, and the properties of inverse matrix are A inverse equal to A inverse E equal to E. Number 2, A inverse equal to E. A B inverse equal to B inverse times A inverse. If A times X equal to B, then X equal to A inverse times B. And the last, if XA equal to B, then X equal to B times A inverse. Fix determinant of matrix order 3 times 3 with a series rule. Matrix 3 times 3 like A equal to A, B, C, D, E, F, G, H, E. And then the determinant of matrix A is brackets A equal to A times E plus B, F, G plus C, D, E minus a diagonal on the top matrix C, E, G minus A, F, H minus B, D, E. And then properties of determinant matrix have 5 properties. And first, determinant A equal to determinant AT. Number 2, determinant change if two adjacent row or two columns in the matrix are swept. And the third, if a row or column of matrix determinant has a factor of P, then P can be output as a multiplier. And that if two rows or two columns are multiplied, then the determinant value is 0. And the last, the determinant value of the upper or lower single matrix is the product of the diagonal elements only.
So the explanation of the matrix is complete. Hopefully it can be useful and see you later.